I'm on the phone with Michael Reynolds from Taos, New Mexico. Michael Reynolds is the chief architect, or should I say biotech, of Earthship Biotecture. For over 35 years, he has researched and developed self-sufficient housing made from recycled materials. His concepts of community living are both earth-friendly and people-friendly, requiring little to no mortgage payment and no utility bills. Considering that, per capita, Canada has the highest rate of energy consumption in the world, the ideas of Earthship are worth attending to. Hi, Michael.
Howdy.
So, can you tell me then, what exactly is an Earthship?
Well, an Earthship is the name we have given to a home that is absolutely independent. It produces all of its own power, harvests its own power, harvests its own water, contains and treats its own sewage, heats and cools itself, is built from byproducts of our society rather than largely trees like most housing is, and produces a certain amount of food. And thus the name Earthship. It's kind of like a ship that will sail on the earth and has everything it needs to do so.
So what materials exactly would one of these Earthships be made of?
The bulk of the structure is what you would call rammed earth, only rather than making forms to ram earth in, we use automobile tire casings to ram the earth in. They're this resilient jacket for rammed earth, so they're fantastic. They make a rammed earth building be much stronger than a normal rammed earth building. And they're very thick walls, so they're resilient. So they're just basically the ideal building material. Of course, there's no termites can bother them, no rot can bother them. They're just a fantastic building material.
So by rammed earth, do you mean that the earth is essentially rammed into these tires?
Yes, it's beat into the tires with a sledgehammer.
And what other materials? I understand did you patent a brick made out of, is it cans?
Well, it started like 35 years ago when we did patent a brick made out of beer cans, the old steel beer cans before they started making aluminum ones. Mm-hmm. And that's what put us, in the frame of mind to be thinking of bottles and tires and other things as well. So it did start with that. We still use cans, bottles, and plastic bottles we're using a lot of. The third world countries have tons of them. And so we're using these materials, the bottles and cans we use as little bricks, basically, for non-bearing interior walls, and the basic structure is made from the earth-rammed tires.
And what about temperature? I understand these Earthships also are able to sustain a fairly stable, constant temperature despite extreme weather?
Yes, they're sort of work on a good analogy is like a flywheel. Once they get stabilized and all the energy is trapped with insulation, there is so much mass that it just stabilizes the airspace. Mm-hmm. And they'll hang, in a worst case scenario, they'll hang between 65 and 75 degrees, free, with no fuel being needed whatsoever.
Right, and I guess what elements of the building contribute to this? Like, how is it able to do this? Is it in part because of the packed earth tires
well, the packed earth tires are the big part of it. Yeah, they provide thermal mass.
Right,
and the thermal mass is trapped in insulation and only admits sun through the south side. And we have double and triple greenhouses to trap it even further. And basically you're storing energy in mass. It's in the principle that's so old as the hills. Architecture just hasn't lent itself to it that much until recently. And so they're just a massive building that is admitting and storing sun heat.
And what about if the temperature outside rises? How do these houses keep the temperature cool?
Well, the roof configurations are set up so that they block the summer sun angle and admit the winter sun. So basically they're masked with no sun
see. And they're partly built underground, too, aren't they?
Well, sometimes they are, but sometimes we bring the ground up around them.
Mm-hmm.
So they can be sunken, or they can have earth brought up around them.
Right. Have you built any of them in Canada? Like, would these buildings, how would they work in the extreme weather of the Canadian North?
They would be fine. At the very worst, say you didn't get enough, if you had tremendous amount of cloudy days, and you needed some backup heat, these buildings would take a fraction of the heat that a normal building takes if they needed heat at all. We get 30 below zero Fahrenheit here, and we get 100 degrees Fahrenheit here in the summer. Mm-hmm. And we have many of these buildings that absolutely have no backup heat. Some of them have a token fireplace or a little token wood stove that they use, 3 or 4 times a year. And in our subdivision here, one of the typical 2-bedroom, 1-bath homes would have a $60 per year total utility bill. That's right. Power, water, sewage, heating, and cooling. $60 per year. Oh. So if that, you translate that into the monetary effect it has on the person, that's great. Mm-hmm. But then you also translate it into the fossil fuel effect it has on the planet. That's phenomenal.
Mm-hmm. And so, in part, I guess that contributes to the little to no mortgage payment that people have to pay.
Well, little to no mortgage payment is if you build it yourself. The methods of building these, we have refined over the years. We have really aimed them at owner-builders so that an owner-builder could build one of these themselves and, only be paying for materials. So there are many situations where there's little to no mortgage payment because you are participating in building your home yourself.
And I guess you could build them anywhere, couldn't you? I mean,
we do them in the tropics. We do them in severe cold climates. Recent projects were Normandy, France, very rainy. Nicaragua, leaving for Jamaica tomorrow. Bonaire, midsummer. So we're doing a lot of tropical ones as well as cloudy, cold climates.
I understand that they're also built to withstand earthquakes or to survive. Was it the Andaman Island?
Yeah, if you can imagine a wall made of resilient rubber tires packed with earth, you can't really imagine that wall cracking.
Right.
And so they're resilient. They will vibrate with an earthquake rather than crack like a rigid concrete wall will.
Mm-hmm. And I understand you've also developed packaged Earthships.
Yes, we basically tried to package the idea so that it could be, it could stand there with the manufactured housing that you bring in and put it on concrete blocks. And we're trying to get this concept to the financial level that the economic level that manufactured housing is, because manufactured housing is the right price. That's the only thing right about it, but it's cheap. And we're trying to get this packaged so that we can compete with that, because people will not go in a green, sustainable direction unless the price is right.
Okay. What about utility companies? Have you come across any resistance from them?
No, not utility companies. My experience with utility companies is that they're so overtaxed right now, they're kind of glad when, that they aren't getting screamed at by people out in the boonies wanting power lines to get built. Mm-hmm. So the utility companies are not, at this point, worried about it because they're so busy trying to deal with the customers they already have.
Okay. Now, so you trained as an architect initially, right?
Yes, I'm a licensed architect in Colorado and Arizona. I have a degree in architecture. Yes.
How did you? What was your experience of that education?
What is my experience?
Well, I understand you studied at the University of Cincinnati, and in the film Garbage Warrior, you described that education as worthless.
Well, That's the truth. Architectural education is tending to teach people. Well, here's the analogy for that. Architecture as a profession is like a bunch of boat builders on the shore of a drying up lake. They are not even relating to the issue. The issue is we no longer can build Gothic cathedrals and architectural masterpieces that take a tremendous amount of energy to run. We need to be building vessels that will take care of people on the planet and not need centralized utilities. Centralized utilities are, first of all, you have to manipulate them and run them all over the place with wires and pipes. And second of all, to cause them to happen. Coal-fired power plants, nuclear power plants, sewage treatment plants that just dump treated sewage into the rivers. These centralized facilities are not cutting it anymore. And so we're looking at decentralizing the utilities and having each building, home or business, run itself. So that makes architects need to be biologists and physicists more than architects that are sort of building little monuments to themselves.
Okay. Well, how did you get started in this environmentally friendly architecture? What was the spark that got you started? Have you always had an interest in?
Well, I got out of here. I was interested in housing. I did my thesis on housing, and when I came out to New Mexico in '69, they were just starting to talk on the news about garbage, beer cans being thrown all over the streets and highways, and they were starting to talk about clear-cutting timber. And these things made an impression on me, and I started trying to use byproducts of our society for building, and trying to kill two birds with one stone, to take these things that were problem materials that we were discarding and use them to build with rather than valuable trees that are putting out oxygen into the air for us to breathe. So that's the kind of spark that started it, and that spark came from the media. The media has made points in the in the TV and magazines and things, and those points have directed me in my thinking to address all of these issues, or try to.
And how did your first attempts work out?
The very first thing we did was a beer can house in 1971, and it's still standing today.
Is this, what is there's a certain compound, is it the Castle compound?
There's one called the Castle compound. That was a bunch of experiments.
Mm-hmm. Did you, you were forced to, you lost your license, didn't you, in, was it 2000?
In New Mexico, yes.
And why was that? Were you encountering...
Well, I was breaking every rule in the book.
Mm-hmm.
We were doing sewage treatment plants, sewage treatment where you're basically running sewage through the living room. But it was clearly done in a great biological way, and is now being done all over the place. I was doing this stuff ahead of the thinking, before, and I'm building with garbage. So just too many things were ruffling the feathers of the profession. And I basically got one or two architects in New Mexico that were on the board of examiners pissed off, actually.
How?
And, well, just due to that they didn't like this direction. They thought this was a disgrace to be built for an architect to be building with garbage and messing with sewage and all of this kind of stuff. They didn't realize the need for it. I think they probably do by now. And they wanted me not to be an architect. And so I had broken enough rules that they could have fined me from here to Kingdom Come. Mm-hmm. And the Attorney General advised me to relinquish my license, and that would make it so I was just a regular citizen, and they couldn't find me as an architect. And then I could go ahead and continue the research and the work that I was doing.
But you've recently been you've regained your license, haven't you?
Well, I haven't in New Mexico. The national board was asked by the New Mexico board to dump me, and they didn't do it at first, but because they said there's no real reason for this, and so they didn't dump me. But then this one guy on the New Mexico board asked them again, please, this guy is a disgrace, and so they did suspend me, and then told me that I could reapply.
Mm-hmm.
And after I did the work in the Andaman Islands, I presented that to them, and they said, yes, you can reapply and you can get your license back. I'm still in the process of doing that because there's a lot of paperwork. But they have invited me to get my national license back. But national license is really all you need.
Right. And you're doing a lot of work overseas now, right?
Yeah, we just got back from Nicaragua. We're headed for Jamaica tomorrow. We're going to Bonaire. The tropical use of this idea is getting real big because in the tropics, almost every tropical paradise is running off of a diesel power plant, so they're shipping in diesel fuel. They are dumping sewage into lagoons that are having a sewage treatment plant that is run by diesel. They are desalinating water in desalination plants that are run by diesel. So what we're looking at is just diesel being shipped to all these islands and nothing being dealt with appropriately.
Mm-hmm.
And these buildings address that, and so they're getting very much in demand in the tropics.
Well, Michael Reynolds, thanks for joining us. We're going to have to draw this to a close. I've been speaking with Michael Reynolds, who is the chief architect or biotech of Earthship Biotecture.